Good morning, students. So let us begin with the new chapter, which is current electricity. Okay. Current, as such, if you have a look at this word current, this current word is not particular to the chapter electricity. It is used for the flow of water also. You call it the current of water. Okay, so in that way, the current word itself is not very specific to electricity. Whereas if you use these two terms together, like current electricity, which is the name of the chapter that we are studying, then it gives you a particular well-defined meaning of what is happening. Okay, so what is current electricity? Current electricity is basically the flow of charges or the flow of electrons, or you can also call that as the motion of electrons. Okay, so but before going into the details of current, we will first have a look at the word static electricity, which we had discussed in 8th standard. If you remember, in 8th standard in physics book, you had a chapter called static electricity, and it is this electricity that we have to differentiate from current electricity. Okay, so if you see the word, here is the word static electricity. Static means not moving. Okay, so if you remember, I'll give you that example which was given in the book. There were certain pair of substances, different material substances, that were rubbed against each other, and because of that rubbing, what happened was that let's say, for example, we have a body A, okay, and a body B. Okay, now initially these bodies are neutral. Neutral essentially means whatever positive charge is there, same number of negative charges are there, same value of negative charges there, which results in these two bodies being neutral. Neutral means uncharged. Okay, so there is a balance of charges that is there in both the bodies. Okay, so now if you rub these bodies against each other, and I have given you the example, let's say for example we had ebonite rod and silk. Okay, so these two materials, when they are rubbed against each other, it is found after rubbing that some of the electrons from one body, they transfer to the other body, thereby resulting in a shortage of charge, or in other words, shortage of electrons on one body and an excess of electrons on the other body. Let's say for example, after rubbing, you have this as the status. Body A develops a negative charge, whereas body B develops a positive charge. So basically, what is the reason why body A has developed a negative charge and body B has developed a positive charge? Essentially, there is no positive charge. It is just the lack of electrons or the shortage of electrons. So that means from body B, some electrons have moved into body A as a result of that rubbing that happened. Okay, so from B some electrons have come into A, therefore A has extra electrons, that is why the negative charge. And similarly, since electrons have moved out of body B, that means body B now has shortage of electrons. So shortage of electron essentially makes it a positively charged body. Okay, so this transfer of electrons from one body to another is basically called the imbalance of charges, and this is what resulted in the static electricity. But here in this particular chapter, we are going to discuss mainly the current electricity, or the current, which is the rate of flow of electrons or rate of flow of charge. So basically here the main or the essential or the important word is the motion of electrons. Okay, so the motion of charged particles, as you see, it is caused by the motion of electrons or the continuous flow of electrons or the charged particles. Now it may not always be electrons, it can be ions also. Okay, you have already studied positive ions which are known as cations, and negative ions which are known as anions. Okay, so in case of an electrolyte or a liquid solution, you have cations and anions which are continuously moving. Okay, so even that constitutes current. In a battery, if you we will go into the details of a battery a little more into the depth to understand how the motion of ions takes place inside that particular electrolyte or the liquid. Similarly, in case of solids, you have the motion of electrons. For example, in a wire or in a metallic conductor, everybody knows that there are a large number of free electrons. Basically, free electron means electrons which have a tendency to flow or to move, okay, to move about freely. Okay, so that motion of electrons in conductors, that is known as the current. Okay, so a general idea now we have got of the word current, electricity. Now, having discussed this, let us now go into the details of what is the reason why the charge flows or why electrons flow from one end to the other or from one let's say position to another. Okay, so for that I have drawn, as you can see, I have drawn a magnified view of a conductor or a wire. Obviously, conductor, you all understand the definition, which allows the current or the charge to flow through it. Okay, so magnified view of a conductor, or you can call it as a wire also. So what is magnified? Enhanced, larger view. Okay, so if I had I wished, I could have simply drawn a wire like this. Okay, but the reason why I have magnified, increased this particular thing in size, is for you to understand what exactly is happening inside that wire. Okay, so if this is a metallic conductor or a wire, you see, again we all know that there will be a lot of free electrons, which will be free in the sense free to move about, okay, randomly. Now, there is no well-defined direction in which these electrons will move, because it is like let's say on a lighter note, imagine a class without a teacher in it. Okay, so the students will be on their own. They will not be sitting quietly. Some will be talking, some will be standing up as you usually do. Okay, so similar is the situation over here. There is no teacher in the class. So what these students are doing is, this is going this way, this wants to go this way, this wants to just be here and talk, maybe this way, and then this way. So this is all haphazard movement. Okay, no well-defined movement is there, and that is why this, we say, is the situation when there is no controlling authority over these electrons. Okay, another example that I can give you is what I have drawn over here. As you can see, there is a ball which is kept on a flat surface or a level ground. So you will see that the ball is actually not moving in any particular direction, because there is no particular instruction given to that ball, or there is no particular let's say a difference in the height which will cause the ball to move. Okay, now consider a situation here, this situation. Okay, the moment you increase the level or the height of point B, over here you see point A as well as point B, they were at the same horizontal level. Okay, therefore the ball was not moving. Okay, it could the ball can actually roll to that side also, it can roll to this side also. There is no particular direction in which you can say that the ball will go. Okay, but if you have a look at the second diagram, now we know that point B is certainly raised to a greater height, so much so that A goes down to a lower level and B rises up. Okay, now you can say with confidence and with 100% accuracy that the ball will certainly roll this way. It will roll down this way. It will roll down from a position of a higher height to a position of a lower height. Okay, so the ball is going to roll down in this particular direction. Now I am going to apply the same logic to the wire that we had drawn over here. Now what I have done is, see, earlier the two ends of the wire were free. There was no controlling authority. Now I have put a battery in place. Okay, so basically what the battery is doing is, now let me show you first what happens. This is the plus end and this is the minus end, or the positive terminal and the negative terminal. So you have a positive essentially here and you have a negative over here. And you know that electrons are negatively charged. So negatively charged particles will move towards the opposite side, which is the positive polarity. So now you can say with confidence that all these electrons will now start moving in one particular direction, which is to the left hand side or to the positive end. Okay, so the net direction of the electrons, now you can see, is from the right to the left inside the conductor. Okay, was this the same case earlier? No, earlier they were all free to move in any direction they wanted, but now they have a fixed direction. Who caused that fixed direction? It is this battery, or the teacher, if you can call it that. This person has instructed all the electrons that they are to move in this particular way. Similarly over here, what was the thing that decided or that instructed the ball that you should go towards A? That particular instruction came from the difference in heights. Okay, so the difference in heights, the moment there is a difference in height created, the ball is going to roll from a higher height to a lower height. Similarly, the moment you develop a difference of potential at the two ends, so now we are going to go into the next terminology as far as the current electricity chapter is concerned, and that is the word potential difference. Okay, so right now I'll give you the details of what the word potential means first, and then I will give you the details of the word potential difference. Okay, but before that, let us analyze it by comparing it with this particular example. So it is like there is no difference in level. Over here, point A as well as point B, they are at the same height. Okay, so there is no difference in the height, so there is no flow. Similarly over here, if you see, there is a difference in the height of B and A. That means there is a difference of height, or there is a difference in the heights or the levels. So the moment difference in height comes, the motion of the ball starts. Similarly, now have a look here. There was no potential difference at the two ends of the wire. So the motion was not well defined. It was all random. But the moment you gave them a particular direction, the moment you created a potential difference of potential, just like you had a difference of height over there, there is a difference of potential word I'll explain in detail a little later. So the moment you create that difference, who creates that difference? The battery. Okay, so the moment that difference gets created, the electrons start moving in a particular direction, and this particular direction is known as the real direction of the current, or this is also known as the electronic current. Okay, I is generally the term, the letter that we use to denote the current. Okay, so this flow of electrons towards, or the drift of electrons towards the positive end, is known as the electronic current or the real current, because this is the reality that is taking place inside a conductor. Now the reason why I mentioned the word reality is because in our life, in our day-to-day examples, the study of physics, what we do is we say that the current is flowing from positive terminal. Okay, so it starts like this, goes up, then goes like this, and then it travels over here, and then it comes down over here, and then this is how the circuit is complete. Okay, so this direction of current that we usually use, this is as per the convention or as per the rule that current always flows from positive to negative. Whenever we say this we are talking in terms of the conventional current. Okay, conventional, or the current according to the rule. Okay, so this is the convention that we follow, from plus to minus. Okay, but as I explained just now, this is not the real direction of current. The real direction of the current is actually the reverse, because you see the electrons are moving in this particular direction, so they are going to move in this particular direction. Okay, so this is the electronic current, and this over here is the conventional current. Okay, so these two you have to remember in terms of the real thing and what we follow as a convention. Now we are going to go into that word potential, and then we will understand another term which is potential difference, which we have got an idea of over here. Okay. Okay, so now let's have a look at what all things I have written over here. For studying this particular chapter, current electricity, as I said, obviously the main term that you have to understand is current, but for understanding current, the deep in-depth understanding of current, you must be able to understand first what is this particular term, potential difference, and then obviously there will be another term which is known as the resistance. So let me first start with the current. As I gave you a little bit of an idea, current, it is the rate of flow of charge. Now that charge can be because of the electrons, that charge can be because of the ions, and so on and so forth. Okay, so the moment the word rate comes, that means we are determining something with respect to time. Okay, so current will be denoted with a capital I or a small I also. So I is equal to, now the definition says rate of flow of charge. So charge, which is represented by Q, divided by time will give you the rate. Okay, so I think you already know this formula, I is equal to Q by T. Now comes obviously the unit, SI, this is the formula. So unit, if somebody asks you the SI unit, so that means you will have to first understand what is the SI unit of charge, Q over here. So the SI unit of charge is Coulomb. Okay, so represented with a capital C, and time obviously you know it is second. So SI unit of current becomes coulombs per second. Okay, and this is also what is known as ampere. Okay, so SI unit of current will be coulombs per second. Okay, please remember that. Now the next word that we come across is resistance. Resistance is basically the obstruction in the flow of charge or current. So it is not always possible that the charge or the electrons will keep flowing smoothly and there won't be any obstruction whatever. No, that is not the case. Depending upon different factors, various factors are there, difference of material, difference of the kind of wire that you have chosen, difference of the temperatures in which the current is flowing through a particular wire. All these we will study in detail. So right now the basic idea of resistance is obstruction in the flow of current. Okay, so more obstruction in the flow of current means more resistance, less obstruction means less resistance. So what is important and logical for you to understand is that more the obstruction, more the resistance, lesser the current. Okay, so obviously you can consider again a very basic example. Consider yourself moving on a bike on a road. Okay, so if the road is busy, that means you will not be able to move faster, or you will not be able to move ahead at a faster pace. You will have a lot of obstruction because of the rush on the road or because of the number of people on the road. Okay, again an exact opposite of this case of this is, imagine yourself driving a bike on a road which does not have any traffic. So essentially that road is all vacant, up to you, so you can go fast. Okay, so road being vacant or having very less traffic means less obstruction. Less obstruction means less resistance, and therefore you can move fast. So more charge or more current can flow if the resistance is small, and less current will flow if the resistance is large. I am talking in terms of the conductors. Okay, now, so having understood the basics of the current and resistance, now let us go back to what I had told you a few moments ago, that we will understand the word potential in detail, because remember, it is the difference of potential that causes the current to flow. Okay, just now I gave you that example of a ball which is lying on a level ground. Okay, so as long as the ground is level, as long as there is no difference in the heights, the ball will not move, the ball will not roll. But the moment you create a slope, the moment you create a difference of height at the two ends, the ball rolls down. Okay, so that difference of heights causes the ball to move. Similarly, the difference of potential will cause the current to move or the charge to move, okay, or the electrons to move, okay. So that is essential as far as the word potential difference was concerned. Now let us come back to potential. Potential at any given point in a circuit. Now what is that? So the definition that your book says is potential at any point is the work done in bringing a unit positive charge from infinity, which is like a extremely large distance, to that particular point. So it is like you have caught hold of a unit positive charge and you are bringing it from a very far off distance to a given point. So obviously if you are doing some work in bringing that charge from a far off distance to a particular point, you are doing some work, okay. So that work is defined as the potential at any point. That means more the work you do in bringing the charge, more will be the potential at a particular point, okay. Now I understand that this is not so easy to interpret, so again I have drawn a very layman kind of an example diagram to help you understand what I am trying to tell you here. Now you see, this is basically a rough looking mountain that I have drawn, and suppose at the ground level there is a person over here. This is the ground level, and he has to climb this mountain, okay. So suppose he climbs the mountain and reaches the particular point A over here, okay. So how much height has he covered? From the ground level he has come up this distance, okay. So he is now standing at A. So do you think that this person has done some work when he has moved from here to here? Yes, obviously he has done work against gravity, because remember, all the time he is going up, the gravity is trying to pull him down. So he is doing the work against gravity, okay. So in reaching to point A, he has done some work W1, suppose, okay. So this W1 work he has done. Now suppose he does not stop over here and he has to climb further. So now this time he goes up, further up, and he reaches point B, which is at an even higher height, okay. So once again the question is the same. Has this person done some work when he climbed from the ground level to that point B? Yes, obviously he has done much more work now in this second case, okay. So let the work done here in this case be W2, okay. So what are W1s and W2s? W1 is the work done by the person to reach point A, whereas W2 is the work done by the person to reach point B, and obviously W2 is going to be greater than W1, which obviously tells you that B is at a higher height than A, okay. So if you apply the same concept to this particular terminology, which is potential, you will understand that more is the work done in bringing the unit positive charge from infinity to a particular point, more will be the potential at that point, okay. Just like the person, when he climbed to point B, he did more work. Why did he have to do more work in reaching B? Because B was at a higher height, okay. So now I hope you have understood. Let me give you a brief example again, a small difference of example. Let's say for example these are 2 points A and B, okay, and I am trying to bring some unit positive charge from infinity, suppose this is infinity, to this particular point A, okay, and my work done is W1. Similarly, I am now trying to bring unit positive charge from infinity to another point B over here, and this time I did more work, okay. W2 was more than W1. So what does this tell me? This tells me that more the work done, more will be the potential at point B. So that means potential at point B is greater than potential at point A, okay. So this is what we have to understand, okay. In order to understand potential difference, we must first be able to understand the word potential itself at one given point, okay. So at this particular point, potential is, let's say, 15 volts. At point B, the potential is 20 volts, so there is a difference in the potential. This difference in the potential is known as potential difference, and this difference causes the current to flow. Now if I connect these 2 points with the help of a conductor, there will be a flow of current, okay, from B to A. Okay, so all these details, how does it flow, from where to where, all that I will explain in detail further on in this lecture. But as of now, I hope you have understood the word potential at any given point. Potential at any given point is the amount of work that you will have to do to bring a unit positive charge from very far off distance to that particular point. If you change the point, the potential will change. Okay, so if you go by this definition, there will be a formula. Potential, which is represented as you can see with a capital V, it is the amount of work done W in bringing what charge? Unit positive charge. So therefore you have to divide the work with the total charge that you are carrying. Okay, so V is equal to W upon Q. When you divide by the total charge, you will get the work done for unit positive charge, and that is what is known as the potential at a given point. Okay. Okay, so now let us move ahead to the potential difference word. We have understood the word potential, and obviously if you consider 2 different points in the circuit or in a wire, and both of these points are at different values of potential, then that means they have a potential difference. Okay, just like I showed you, the moment I created a slope between points A and B, that means I created a height difference. Similarly, the difference of potential can also be created in a circuit or in a wire, and this difference of potential will cause the flow of current, just like the difference of the heights created or caused the ball to roll down. Okay, so in this particular term, let us come back to what we have to discuss particularly or specifically. This was that magnified portion of the wire that I showed you. Obviously there are a lot of free electrons inside it, because it is a conductor, or it is a wire which can conduct electricity. It can conduct electricity because of the availability of large number of free electrons. Okay, but till the time the battery is not there, the electrons will not flow in any particular direction. That means there will be no net current. Okay, but the moment you create a potential difference by inserting a battery, you see now this is a 15 volt battery. I have told you that the SI unit of the word potential, as you can see over here, the formula we had discussed, potential at any given point is defined as the work done in bringing unit positive charge from infinity to that particular point. So this was the formula discussed, and obviously from this formula you can get the SI unit of potential also. Work has a SI unit of joules, and charge Q has the SI unit as coulomb. Therefore the SI unit of potential will become joules per coulomb, or this is also known as volts. Okay, so the SI unit of potential, or for that matter potential difference, is joules per coulomb. Okay, and this joule per coulomb SI unit is also called as volts. Okay, so from now onwards, whenever we will talk in terms of potential or potential difference between any 2 given points, we will always use the unit volts. Okay, so here you see, but because of the insertion of the battery, what has happened is, this is a 15 volt battery, so it has created a potential difference at these 2 ends of the wire. This potential difference is of the order of 15 volts. That means as long as there is a potential difference between these 2 points, there will be a current flow. Because always remember, even if you forget this particular specific example, always remember the example of the ball. The ball only rolls down in a particular direction if you create a difference of heights. Similarly, the current will flow in the wire if you create a potential difference between any 2 ends of the wire, and that potential difference is usually created by the help of a cell or a battery. You can have different strength of the battery. It can be a 5-volt battery, it can be a 20-volt battery, and so on and so forth. Okay, so a very quick example over here. If you see, if it requires 20 joule of work to bring 10 coulomb of charge from infinity to a given point, calculate the potential at that point. Okay, so potential at that point, the formula I have already discussed a number of times. W upon Q. W is the amount of work done. So how much work is being done? 20 joules. What is the charge that you are bringing? 10 coulomb. Okay, so when you divide by 10, you will get for 1 coulomb. That means 0 gets cancelled. So you have 2 joules per coulombs, or you can also say, as I have mentioned over here, 2 volts. Okay, so this is the 2 volts is the potential at that particular point. Okay, now we are going to move to the term resistance in detail. So as of now, we have discussed static electricity, difference between static and current electricity. What is the reason why charges flow? Okay, what is current? Current is the rate of flow of charge. So the faster the charge moves, the more the number of charge moves in 1 second, more is the current flowing. What is that reason which causes the current to flow? That reason is potential difference. Okay, so yes, by the way, now that since we have reached this particular point, let me also give you a further step to this logical explanation. I have right now inserted a battery of 15 volts. Okay, so suppose there is a current flow of let's say 5 amperes. Okay, what if I replace this battery and insert a battery, replace this battery with, let's say, 20 volts battery or a 25 volt battery? So if as a result of the increase in the potential difference, there will be a similar increase in the current flow also. Okay, so basically this potential difference is the one responsible for the current flow. Please remember that. Okay, now let us go on quickly to the resistance part in detail. Okay, so here we are, resistance represented with a capital R, and I have already given you a basic idea. It is the obstruction in the flow of current. More the obstruction, more the resistance, lesser will be the current flowing. Okay, so now it goes further than this. If you logically think about a wire, now let me once again draw a magnified view of a part of a wire. Okay, now this is a magnified, enlarged view of a wire, okay, through which the current is flowing. So current is flowing means what? Free electrons are moving. Okay, so suppose there are a lot of electrons all around. Okay, now for ease of explanation and for ease of understanding, I am only drawing 5 or 6 electrons, but obviously you all understand that any given piece of conductor or wire will have thousands and millions of free electrons available to move. So in that given particular space, if you can imagine so many electrons moving around, there is bound to be collision between the electrons. Even if you insert a battery, let's say for example, even if you insert a battery and there is a particular direction in which the electrons are flowing, but still you can easily imagine them colliding with each other continuously because of such a large number of electrons that are moving, and they are continuously increasing. They are moving with continuously increasing speed. Okay, so there is bound to be collision, and that collision is that obstruction that I am talking about. Okay, now let us consider the length of the conductor. Suppose you choose this much length of a conductor, and in the other case you choose a much longer conductor or much longer length of the wire. Obviously the resistance will be directly proportional to the length of the conductor, because the more you have to travel on a busy road, the more obstruction you will face. Okay, so it is that logical to understand. Similarly, you can talk in terms of electrons also. The more longer distance they have to move, more number of collisions will be there. Therefore, resistance will also be more. So, more the length of wire, more the resistance. So, there is a direct relationship. Whereas, if you see, if I increase the area of cross section, that means I make the mouth, this is the area of cross section that I am talking about, that basically means a much wider space to move. So the electrons will be able to move relatively easily. So that means with the increase in the area of cross section, the resistance drops, okay, because it becomes easier for you to move. It is just like imagining yourself moving on a big wide road, okay. So wider the road, easier it is for you to move on it, okay. So lesser the obstruction, okay. So here, as you can see, as a result of this explanation, resistance of a wire is inversely related to the area of cross section of the wire or the conductor, okay. So these two things, they are quite the opposite effects on resistance, okay. If you take a longer conductor, resistance will be more because the length is more, whereas if you take a wider, much spacious, if you can use that term, conductor, then you will have a lesser resistance, okay. So this is the first relationship and this is the second relationship, and when I combine these two, I can easily write this is the same resistance. R will be proportional to L, because L is direct relationship and A is inverse relationship, okay. So combining these two, I get this, and when you remove the proportionality sign and equality sign comes, there is a constant that comes, and this constant is known as rho, okay. The pronunciation is rho, R-H-O, okay. The symbol is this. It is not a P, it has a curled tail, okay. So this is known as known as rho, but it represents a constant. It has a fixed value for a particular material of a wire. So rho is a constant called resistivity of the material used in the wire. Obviously, all conductors are not made up of the same material. You can have a copper conductor, you can have an aluminium wire, you can have a nickel wire, or a wire made up of an alloy, okay. So different materials, what will change? Rho will change, okay. So this value rho, although we are calling it as a constant, but it is constant only for a given material. So if you keep choosing copper wire everywhere, 1 meter of copper wire, 2 meters of copper wire, 3 meters of copper wire, what will be same in these three cases? Yes, the material is the same, therefore rho value or the resistivity value, by the way, this is also known as specific resistance, okay. So rho value will be same as long as you are choosing the same material wire, okay. So using these two situations or conditions or relationships, we have come to a third formula. Remember, if you remember, there was a current formula, there was a potential difference formula, there was a potential formula, and now we have come to the resistance formula. R is equal to rho L upon A, okay. Now have a look over here. Resistance of a conductor depends upon, okay. So essentially over here we have to discuss conductors or metallic conductors or wires, okay. So what does the resistance of a conductor depend upon? So the first two things now you are very familiar with. Length of the wire. You take a longer wire, resistance will be more, okay. Then area of cross section, inverse relationship. You take a larger cross section, resistance will drop. But from where are these two coming? If you see, the resistance formula only has length and area in it, okay. Rho obviously is a constant. So where are these two factors coming from? It is very logical for us to understand the remaining two options that are there, or remaining two factors that are there. Temperature of a wire. Now suppose this is that wire which we are talking about, and we are sending current through it continuously. After a large interval of time or a long interval of time, it is bound to get heated up, okay. So the wire, you all have experienced it in your homes. With continuous flow of current for a long time, the wire gets heated up, and it is that heat which gets imparted to these free flowing electrons, and they become even more vigorous, okay. So it is like you provide a lot of energy to these moving electrons, and then they start moving even more rapidly, okay. So the faster you move on a busy road, more collisions and more obstructions and more accidents are bound to take place, okay. So if you increase the temperature of the wire, what is going to increase? The resistance is also going to increase. So now if somebody asks you, if you increase the temperature of a conductor or a conducting wire, what will happen to its resistance? Its resistance will also increase. Okay, and fourth point, obviously now you must have understood material of the wire. This material of the wire is coming into this particular factor, which is rho, because this rho is called resistivity of the material used in the wire. So this rho will have a fixed value for a given material. If you take copper, rho will have a different value. If you take aluminium, it will have a different value. Okay, so depending upon different materials, rho will have a different value. Now coming on to the last part of this particular lecture, we have discussed the SI units of current, we have discussed the SI unit of potential, we have to discuss the SI unit of resistance also. So for the time being, before we go into Ohm's law in the next lecture, let me give you resistance. The SI unit for resistance will be ohms, or when we will study Ohm's law, we will also study that it is volt per ampere. Okay, so for the time being, this is a symbol. This symbol is known as omega, by the way. Omega, this symbol is called omega, and what does this symbol represent? It represents the SI unit of resistance. Okay, so this is known as ohms. Okay, ohms. So resistance, now I'll write down, SI unit of resistance is ohms. Okay, please remember this. SI unit of resistance of any given conductor or a wire is ohms. Okay, this ohms we will study in detail when we study the Ohm's law. What is Ohm's law? All that detail we will study. So resistance is the obstruction in the flow of current. That obstruction depends upon a number of factors. In case of a conductor, please remember that there are different types of materials that we have. We have conductors, we have insulators, we have semiconductors. Okay, so do not get confused with these factors and those other things. Our prime emphasis as far as our syllabus is concerned will be with regards to conductors. Okay, so most of the things that we are studying with respect to conductors or wires. Okay, so I'll finish this lecture over here. I hope you go ahead and study this in detail. The first assignment that we will be giving will come after I have done the second lecture also. Okay, so once you go through the first couple of lectures, then I'll give you the first assignment. Okay, thank you, students.